So let's think about this equation. What happens when you plug in a 0? 2 to the power of 0 is 1, plus 1. Your intercept is 0, 2. And from there, we go up exponentially. We are taking the negative version of this same function. So we'll start at negative 2, and we'll go down. So C meets both of those criteria. It starts at negative 2, and it goes down. This one has the wrong intercept. This one's going the wrong direction, the wrong intercept. If we decay at a rate of 13%, we take 100 minus 13 divided by 100, and that's how we get 0.87 for our decay factor. The initial amount is 325, so we multiply that by 0.87 to the power of t. That's why A is the right equation. What this equation tells us is we have an initial value of 215, and we are increasing by 0.5%, and this is happening every 3 years. Every 3 years we increase by 0.5%. So 3 years has 36 months in it. They want to know how many months will it take. The answer is 36. So this graph will start at, if you put in 0, it'll be 4 minus 2, or 2. So our intercept is going to be 0, 2. And as x gets larger and larger and larger, 1/2 is going to multiply over and over and get to be a smaller and smaller fraction. So we are going to get closer and closer and closer to y is equal to 4. So I'm looking for the intercept 0, 2, which is either B or C. And I'm looking for, as x gets bigger, we approach 4, which shows up here for C. This tells us we started with 12, we are doubling every 6 days, t over 6. So they want to know what 2 to the t over 6 means, and that means it doubles every 6 days. Our variable t is the time in days, and when that reaches 6, we take that number to the power of 2 to the first. So 12 times 2, that's when it doubles. They're asking about the number 1.11. So we start off with this initial value. We are increasing by 11% every number of days after June 1st. So that's the growth factor. This is how many we started with. We're not increasing linearly. And it's not how many days it takes to double. This is every day we multiply by 1.11. If the half-life of a certain substance is 150 years, we're going to multiply our initial value by a growth factor of 1/2. And how long does it take to do that? Well, it says 150 years. So we want to be able to plug in 150 for t and get 1/2 to the power of 1. So if we plug in 150 here, we don't get 1. This is going to be way bigger than 1, way bigger than 1. D is the one that works. Initially, there's this many bacteria. That's our starting value. We double, so that's our growth factor of 2, every hour. And x is the number of hours. So here's the equation to represent the number of bacteria. Our initial number is 10,000. So we have an equation like this. We double every 12 hours, so a growth factor of 2. And we're going to take x divided by 12 for the exponent. So if I plug in a 0, I have 0, 10,000. Now they tell me y is in thousands, so that's really 0, 10, which shows up on every graph. And it's going to take 12 hours to double. So the next one will be 1220. Then it'll be 2440. A couple of these have 1220. Or at least it's pretty close. A couple of these don't have it. If I look for 2440, this one has it. This one has it. So let's go a couple more points. 48 should be 160, which is right here. This one has 48 much lower, so A is the right answer. If this is f of x here, how do I get f of x minus 2? Well, I just move the entire graph down 2. So instead of crossing at 0, 2, we should be crossing at 0, 0, like C.